as, you know, a group that instead of having your cumulative grade in Q, what you're going to have is just your Q2 grade in Q. Now I'm going to tell you a few things because some of you might look at that and you'll be like, oh my gosh, what happened? Okay. If you go into Canvas, you will see in Canvas your grade that is cumulative from the beginning of the year. Some people wanted to see the cumulative grade, so I left it up there so there's a cumulative grade. If you go into Q, you will only see your Q2 grade. Now, the thing is that gets a little tricky is that anything that's graded in Canvas has to be pushed into Q, right? So as soon as I grade something, it does not mean that it's pushed into Q. It's graded in Canvas, so you can look up everything individually in Canvas and see how you did on each assignment. But it gets pushed out to Q. So what I did last night, I was up to like 10:30 last night. Plug it in, Juliana. I was up till about 10:30 last night grading. And so I pushed the grades out this morning. So you'll see that some new grades went on to Q for you. I do not push out grades for every single time I grade one person's assignment. I will push out grades in the morning, and I'll push out grades at the end of the school day, like around 3:30. So if I've graded your assignment within those time parameters, you will see that the grade will be pushed into Q. Now, this is something that I learned. You know, we're very used to immediate gratification now with computers and everything like that. As soon as we hand something in, we think that it's going to be graded right away. But the reality of it is that I have 200 students. Some people are handing assignments in late. So I still have to grade those. Plus I have to grade the assignments that you're handing in. It's not immediate gratification. I am not going to grade it the very second that you hand it in. The other thing is when I pushed the grades out the first time, I didn't see them go into Q. So I immediately called my Canvas contact and I said, hey, I don't see my grades in Q. They're not in there. And she said, oh, Nancy, you're so funny. It's not immediate gratification. It takes a little bit of time for the computer to sync up your Q grades and your Canvas grades. So just give it a little bit of time. Now, if you want to know how you did in each assignment, you can still look at that on Canvas. If you're just interested in knowing what your grade is, overall grade, you can look in Q for your Q2 grade. Don't take your cumulative grade from Canvas, just your Q2 grade from Q. Does that, give me a thumbs up, give me an okay, give me a yeehaw, give me a something in the chat if you know what I'm talking about. Yes, yes, Tyler, I saw your email. Yeehaw, thank you, Parker. Got it, Aiden, good. Jazz, yee, I'll take that. Thumbs up, yeah, yeehaw, perfect. Okay, okay. So again, Q2 grades are the grades that you're going to receive on your report card. Q2 is not over until the end of January, right? So we have some time. Why are you sorry, Logan? Okay, Cyan, thank you. All right, so yeah, so you'll be able to look for your Q2 grades on there. That being said, now that we've talked about grades and we've talked about what's due tomorrow, module 7. Oh gosh, yeah, Mia, your Q2 grade, Q2 is not over until January 26th, I think. Let me look at my calendar. Maybe January 22nd is the last day of the quarter. Yeah, January 22nd is the last day of the quarter, so you have plenty of time. That's okay, Madrid, you're fine. So yeah, you're good. You have plenty of time for your Q2 grade. Don't stress over that. But what I want to remind you is that you have 2 attempts to take quizzes. So if you don't do well the first time, really take your time the second time. and you have unlimited attempts for handing in assignments to do better on. Okay, so please, anytime that I return work to you, you'll get it in recent feedback. Look at my feedback. I take the time to write notes to you guys on how to change certain things. I will tell you that the Bill Nye video worksheet that you guys did, many people, for some reason, and I remember specifically about this Bill Nye, is that questions 1, 4, 10, and 14 all weren't fill in the blank, but like question 1 asked about atoms make up few or many things, whatever the question was, and you have to choose either underline or circle one of those 2 words. A lot of people are not doing that. So I'm sending information back to you guys saying that you're missing questions 1, 4, 10, and 14 because it's that type of question. But I'm reading through all of them. Don't think that I'm not reading them. I'm reading through all of them, and I'm taking my time to write notes to you guys. So I'd like you to take the time to read them, and then you can correct them, and then you can hand them back in. Yeah, and I think Juliana actually handed one back in last night. I graded hers a second time, I think. So yeah, you have unlimited attempts to get an A. If you want 100%, you have unlimited attempts to do that. All right. People are saying, do you have extra credit? My extra credit is the unlimited attempts to get 100%. It's not like, you know, when you're at school, I don't give you the opportunity to hand an assignment in 12 times in a row to get an A, do I? No. So that's your extra credit, is the time to do it. Okay. Today you're going to take some notes, and I'd like you to please take out, like I said, a piece of paper and something to write with. Some of you might like to take the notes in the chat and highlight them and copy them onto a Word document. Whatever works for you is fine with me. Okay, what I'd like you to do is, on a fresh sheet of paper, I would like you to leave a couple of lines on the top blank. And then beneath that, I want you to actually do this. Take the piece of paper, fold it in half, lengthwise. So it's like a hot dog bun, right? Fold it this way, not this way, but this way. Fold it lengthwise. So it splits the paper in half, side by side. And on the top of the paper, you're going to write this information that I'm going to tell you. You guys have heard this, you know this already, but I just want to make sure that we have the same information on the paper. That matter is anything that has mass and takes up space. Matter is anything that has mass and takes up space, right? So matter is all around you. It's everywhere. Matter is anything that has mass and takes up space. Now we're going to talk about that matter a little bit more, and we're going to break it down into two. That's why I had you do the paper in half like that. 2 sides of the paper for some type of like comparison. Okay. On those 2 sides of the paper, one column is going to be labeled physical properties. Physical properties. And the other column, which is next to that, is going to be chemical properties. So now beneath the physical properties, I'm going to put PP, beneath the physical properties, write this definition down for me, please. Physical properties can be observed or measured without, and without is a very, very, very important word, without changing the matter's identity. Okay, So physical property is anything that can be observed, and we use our eyes, right? So you can see it, anything that can be observed or measured, sorry, that should have a D there, measured without changing the matter's identity. So that means like, I'm going to give you a whole list of them. We talked about many of them already. I'm going to give you a whole list of them that are going to make sense to you guys. So you're going to write this down in a list. I don't care if you number them or you do them bullet points. It's up to you. Whatever's going to work best for you. I'm going to talk first about the ones that we've already gone over, okay? So one of those with physical properties is thermal conductivity, which means can conduct heat, right? And when we talked about the periodic table of elements, we talked about metals. And metals, one of metals' physical properties is that it has the ability to conduct heat. Metals are really good conductors of heat, and we've talked about that, right? You have your metalloids, which are semiconductors, but metals are really good at conducting heat, and that's thermal conductivity. The next one is ductility. Ductility, whoops, is the ability to be pulled and made into wire. So we specifically spoke about copper, right? Copper is very ductile, meaning that it has the ability to be pulled. We use copper for a lot of wiring. These all go underneath physical properties. Good question, Mia. These are all physical. Do not write in chemical yet. I'm going to give you all the physical properties. There are about 8 physical properties, and I only have 2 chemical properties. Okay, so right now we're just going to focus on the physical properties. So we talked about thermal conductivity. We talked about ductility. We also talked about malleability. Malleability is the ability for something to be rolled or pounded into sheets or different shapes without breaking. So when something is malleable, and we said this about metals, right? Metals are definitely malleable. I can pound them into shapes. The other day, my friend was taking down a bench that he built, and he had used metal attachments in the concrete to the bench to hold it stable. And so he left them in the concrete. And what he did is he took the butt end of the metal and he just pounded it down. Metals are malleable, right? We know, we see jewelry, we see metals can be made into different shapes. And the easiest one to think about is aluminum foil, right? In your kitchen, a lot of times you probably use aluminum foil, and it's pounded into sheets. So now you should have thermal conductivity, ductility, malleability, right? The next one we're going to talk about is hardness. Hardness is a physical property. So there's this fella, he came up with the Mohs hardness scale. I don't know if you guys are aware of what the Mohs hardness scale is, but I know that many of you like Minecraft, and Minecraft has been really helpful in describing some things. There's this scale that rates how hard different minerals and substances are, right, on the periodic table of elements. And the scale ranges from a 0 to a 10. 10 means that it is the strongest substance. Type in the chat if you can tell me what is a 10 on the periodic table of elements. And this is something that you would have seen in Minecraft. Maybe if you like to do woodworking. I know Mr. Fredette has some drill bits in which this is on it. It's a very, very, very strong substance. Does anybody know what it is? It's a girl's best friend, or so they say. Not neon. Good try, Parker. Yes, Mia. Diamonds. Yes, diamonds. So diamonds are a 10 on the Mohs hardness scale, which means that they are very, very strong. So if you think about drill bits, right? Different drills. On the drill bits, they use diamond dust because the diamond dust strengthens that drill bit. On the other end of that scale, down by the 0, is something that's called talc. Talc comes from a rock. Talc is a powder. Maybe you've heard the term talcum powder, or you can find, you know, talc mixed in with other powders. It's a rock, and you can actually take your thumb and scratch and break the rock with your thumb. It's so soft. Okay, so talc is on one end of the spectrum, really soft. Diamonds are on the other end of the spectrum, really hard. If I have a diamond, the diamond's hardness remains the same. Hardness doesn't change. They could be miles, absolutely, yes. And the rocks that you can draw with and they crumble, like, so you can, like chalk, right? Yeah. There are different rocks that do that though, like red rocks do that also, which is not talc. So it depends on the rock that you're talking about. In between on that spectrum, you have other minerals, other elements. So I'm going to talk about topaz because topaz is my birthstone. Ooh, no, Lonnie. Hang on a second. Topaz is my birthstone, right? So if you're born in November or December, you're either yellow topaz or blue topaz. Topaz falls on that hardness scale, and it is not nearly as hard as a diamond, but it's a lot harder than that of talc. So I think topaz fits between like 7 and 8 on the Mohs hardness scale. Quartz. If you're born in February, your birthstone is an amethyst. Amethyst is a type of quartz. Quartz also falls around 7 on the Mohs hardness scale. So it's not going to change. If I have any type of quartz, it's going to be the same on the Mohs hardness scale, and that's something that we can measure. Lonnie, what are you saying about sandstone? Can you write with sandstone? Is that what you're saying? I don't know. I don't know. Honestly, I've never tried it. I always had like chalk to write with, so possibly. Okay, so we have hardness, you have thermal conductivity, you have ductility, you have malleability, you have, now I'm going to add color. So let's take this and put it to everyone. Color. Color is something that you can see, and color that does not change. Is a physical property. So for example, you know, I talked about this and everybody says that emeralds do nothing for you in Minecraft, except something with fish. I have no idea. But emeralds are green, right? Green emeralds are going to be green. They're not going to change color while you're wearing it or while you're looking at it. It's going to stay green, okay? So color is another physical property. We only have 2 more, I think, to add to this. The next one is density. And I need to spell it right. Density. And you guys may have seen density equals mass over volume. Maybe you learned about that last year. In order to take the mass of of an object, what I have to do is put it on a triple beam balance, and I can take the mass of it. Remember, we talked about it in the beginning of the year. The mass, you measure the mass of an object in grams, whether it's milligrams or kilograms, the mass of an object is measured in grams. And the volume is taken, if it's a cube, you can do it mathematically, length times width times height. But if it's an irregularly shaped object, remember we said we can use water displacement. We can put it into a graduated cylinder and see how much the water rises. This is all for physical. I've not gone anywhere. I think there's one more left for physical after this one. There's a lot of physical properties. Density. Let's say I am mining for gold in Minecraft and I hit the mother lode. I don't know if you can or not, but in my world, you can hit the mother lode. And I'm mining for gold and I find tons of gold. But my gold is in different sizes. I have a huge chunk of gold and then I have a small nugget of gold, right? Just because the size is different does not mean that the density is different. The density of gold will always remain the same density as any piece of gold that you have that is true gold. It does not matter the size because you're taking the mass and dividing it by the volume. Anytime you have mass and volume of the same substance, you will always end up with the same density. Okay, so now we have thermal conductivity, malleability, ductility, density, color, hardness. Did we talk about state yet, or state or phase? Okay, phase or state of matter is, oh, that went to Lonnie privately, sorry. Phase or state of matter is another physical property. So you can see what phase something is. We could either say a phase of matter or a state of matter. Let's take ice for a second. Ice is water. It's just frozen, correct? Liquid water is a liquid. So now I have a solid and a liquid. Water vapor is gas. They're all still water. They're just in different phases. You haven't changed the water in any way, right? The matter is still the same. It's just in a different phase. So it doesn't matter whether it's a solid, liquid, or gas. Those would all be physical properties. And then I have one more. This is the last physical property in your list. And that is solubility. Solubility is the ability to dissolve. So I don't think it's far-fetched if I ask you if you know what Kool-Aid is, or you know what Crystal Light is, or you know what, those little packets that you can add to your bottle of water to flavor your water. All of those substances have solubility. Sugar has solubility, which is generally what those are made of, right? Salt has solubility. Kool-Aid has solubility, yes. All of those have solubility, which means it has the ability to dissolve in a solvent, okay? So there's solute and solvent. The solute is what you're trying to dissolve in the solvent. The solvent is the substance that you're dissolving it in. So salt water, right? The ocean is salt water. The salt is in the water. It's been dissolved, right? Maybe you've taken salt and you've added to water so you could dissolve it and swish your mouth with salt water. Many people drink tea, and in their tea they put sugar. The sugar dissolves in the hot water, right? So sugar has solubility. Kool-Aid, anything like that has solubility. Those are all of your physical properties, okay? Those physical properties can be observed or they can be measured, and we are in no way changing the matter's identity. If I have salt water and I let the water evaporate, it's changing the phase of the water. It's going from a liquid to a vapor, and then I'll be left with the salt, right? So it's all still there. I've not changed the identity in any way. But with chemical properties, it does have a change in the matter's identity. So chemical properties I told you when I would switch columns, so now we're in the next column. There are only two things that I'm going to give you for chemical properties. Chemical properties include reactivity, and number two is flammability. And we'll talk about those two. There are only two chemical properties. Flammability is probably pretty obvious to you guys, right? Fire. Fire scares the living daylights out of me. I don't like fire. When something is flammable, we say it has the ability to burn, right? That one's pretty simple. If I take wood that is dried out, that's not living, I can burn it in my fireplace, I can burn it in a campfire, whatever. I can take a piece of paper and I can burn it. There are different elements that are very reactive, and you can easily burn different elements. There are some elements that can't be burned at all. Hair can be burned. Hair smells terrible when it burns, in my opinion. Yes, hair can be burned. So flammability is one property, one chemical property. The other chemical property is reactivity. Okay, reactivity means that the matter has the ability to change into another substance. So, there was something that was given to the United States as a gift, a very large something that was given to the United States as a gift. And it resides in New York, in the water. And it's made of copper. Yes, Arden. If you know what it is, let me know. Yes, Parker. Yes, Aiden. Very good, Travis. So this is a statue. Yes, 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 yes. Some people call her Lady Liberty. The Statue of Liberty is made of copper. And if you look at a penny, or you look at a copper wire, and then you look at the Statue of Liberty, they don't look the same. And the reason that is because the Statue of Liberty has been living in the elements, if you will. And when I say the elements, I'm saying living in outside in the weather, right? There's salt water there. There's different types of weather, rain, snow, sleet, hail, wind, and all of those cause the Statue of Liberty, that copper, to oxidize. Oxidation is a type of reaction that's happening chemically. So the oxygen, affects the copper itself, and it turns it to that greenish color, bluish green color that you know of as a Statue of Liberty. The Statue of Liberty used to be copper, as you would imagine the color copper to be, right? But because of oxidation, a chemical reaction is taking place, and there's reactivity, hence the word reaction, reactivity, right? That is a chemical property. If if I were to leave my bicycle outside for days, months, weeks, no, days, weeks, months, years, what would happen to my bicycle? More than likely, if I leave it outside, yes, Aiden. More than likely it will, Lonnie. Yes, Parker. It will change. How will it change, Miles? Yes, Lynn. The paint would flake, probably, and yes, it would definitely rust, okay? And especially here, because we are close to the ocean, we're coastal, right? And there's a lot of salt in the air, salt water, we're right by the ocean, and the salt affects the iron itself from the metal that's making up the bicycle, and it causes the bicycle to rust. If you were to go outside and look at like a fence by your house or something that's put together with nails, and you look at those nails, the new nails are no longer shiny nails. They are rusted because they've been there's been a reaction that's taken place with the oxygen and the weather, and it's caused the metal to rust. Growing up in New York and living in Alaska, does anybody know what you would put on salt to make it melt? I mean, I just gave it away. Not that you would put, that you would put on ice to make it melt. People put salt down on the roads, right? And so the salt causes the ice to melt so that it's not as treacherous to drive on or to walk on. The salt can damage the undercarriage of your car. So you should wash your car frequently, just like the salt air can damage your automobile here or your bicycle, okay? Because there's a chemical reaction, reactivity, some kind of chemical reaction is taking place, causing it to rust. Does that make sense? Give me a thumbs up or a yeehaw if you guys are still here with me. I see a couple of you. All right. I love jazz. Yee. All right, cool. Perfect. Thank you, thank you. Okay, so now we did physical properties and chemical properties, but there are physical changes and chemical changes. And we just talked about some chemical changes happening, right? The easiest one that I'm going to talk to you about, I think, is physical change, right? So you're going to take this down. A physical change is where no new substances are formed at all. So, for example, if I have ice and it melts, it becomes water. And if I heat that up, it becomes water vapor. It's going from solid to liquid to gas, but it's still water, right? It's a solid water, a liquid water, and a gas water. Water vapor, water, and ice. So whenever I have a phase change, that's a physical change. I have a piece of paper. If I take that piece of paper and I tear it in half, it's still paper. It's just two pieces of paper. That's a physical change. I've not done anything to it except made it smaller, but it's still paper, right? Do y'all agree with that? Oh, wait, I wrote the, oh, Lynn, you should have told me. I wrote the definition down privately to Lynn. There you go. Physical change, where no new substances are formed. I'm taking the paper, I'm tearing it in half. I've not created anything new. It's still paper. If I had a soda can that was empty and I took that soda can and I squished it on my forehead, is it still a soda can? Yeah, it's just a squished soda can. Do I have a bump on my head? Probably. If I take a pencil and break it in half, no, this is physical, Kylie. This is physical. Physical is where there are no new substances formed, right? So if I take something, let's say I go to the forest, let's say I'm a lumberjack and I go to the forest and I cut down a tree. Is it still a tree? It's just a fallen tree now. It's still a tree. I haven't done anything to it chemically. Oh, Jaden, don't do it. If I have a pencil and I break my pencil in half, don't do it. Is it still a pencil? It is a pencil, but look, Jaden did the experiment for us. It's still a pencil, but now it's two pencils instead of one, right? If I have a piece of paper and I tear it in half, is it still paper? It's still paper, but it's two pieces now. If I go from ice to water because I've added heat, is it still is it still a physical property? It is, because you're going through phase changes, right? Your water, when it turns to water vapor, is still water. It's just a vapor. It's a gas. Your water, when it freezes, it's still water. It's just frozen water. So those are all physical changes. If I were to take my hair and cut my hair, is it still my hair? It is. It's just shorter hair, right? However, and I don't know if anybody has this, and if you do, turn your camera on for me, please. If I were to take my hair and change the color, I know like Ben has his hair is blue, right? Anybody that has dyed their hair has chemically changed it. There's been a reaction. So when you cut your hair, it's just a physical property. It's still your hair, you just cut it, it's shorter. But when you dye it, you change it chemically, and a reaction has to take place. So we have physical changes, and then we have chemical changes. Okay, so we talked about physical changes and when no new substances are formed. Chemical changes are when new substances are formed and they have different properties. That's the last one you're going to write down today. And I'll tell you what I mean by that. Let's say I'm not lumberjack and I go into the forest and I cut that tree down. It was a tree standing. Now it's a tree on the ground. It's still a tree. Let's say I take that tree and I let it dry out and I cut it into logs. It's still the tree. It's just in smaller pieces, right? If I take those logs and I set them on fire in a little a campfire, right? Those logs, the wood, is no longer the tree. Those logs will turn into ash, and a lot of the elements will go up in smoke, right? Will go into the atmosphere. When the logs burn, the smoke goes into the atmosphere. So the matters change. There are different properties because that log was, again, we'll talk about flammability. If you add flame to something, you're going to change it, right? Chemically. Give me a thumbs up if that makes sense, or a yeehaw, or I'm good, or I kind of get it. Yes, good, Arden. Thank you, Aiden. Okay, because on Monday, we're going to have a whole list of them to go through. Yeah to the yes. Okay. Thank you, Cyan. All right, so that's all I have for you. Good job, I'm glad. Okay, that's all I have for you for notes today. On Monday, because I don't see you again until Monday, there's no module 8 going out to you guys. Don't worry about it. I'll push it out on Monday, but it's not going to be due for a couple of weeks because next week is a short week, right? We only have Monday, Tuesday. So I'll push out module 8 on Monday. I'll talk to you guys a little bit about that. We will do a few things with chemical and physical changes. And yes, because of Thanksgiving. And that's all I got. If you guys need anything from me, I am here for you. Just send me an email, or if you want to set up a Zoom, I can help you out with that. Otherwise, have a great, great weekend. And I will see you next